Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about the technique signal flow graph which is used to represent the control systems. So let's start with our topic. In our earlier videos, we have studied the block diagram technique for representing the control systems. In the block diagram technique, it involves a number of blocks and feedback blocks are also involved in it. So the representation of a control system using the block diagram technique, it is very complex and it is very confusing. So there is another technique called the signal flow graph technique which is used to represent the control systems. In the signal flow graph technique, it is a representation of a set of equations. If we apply the Laplace transform on the transfer function, we will obtain the differential equations. Okay, so those equations, they can be represented using the signal flow graph technique. So we can say that a signal flow graph is represented by a set of equations. If we take an example, we have a simple block diagram in which the input is xs and output is ys and the transfer function is gs. So this is the block diagram, a very basic block diagram of a system in which the input is xs and output is ys. Now if we represent this system by the signal flow graph, then we have So this is the signal flow graph representation of this system. In this we have two nodes. One node is for the input which is named as X and another node is for the output which is named as Y. And between these two nodes we have a branch on which we have an arrow which is showing the flow of signal, that is the direction of the arrow. It is showing that the signal is flowing from the X node to the Y node. So the nodes are connected by the branch and on the branch we have the arrows which indicates the direction of flow of signal. So we can say that a signal flow graph, it is the representation of the system in which the flow of signal is represented. Okay. So this type of representation, it is called the signal flow graph technique, and in this signal flows from one node to another node. Now let us study some of the terms which are commonly used in the signal flow graph technique. So let's see the basic terminology we can say of the signal flow graph. The first term which we have introduced in this signal flow graph, it is the node. So what is a node? A node in the signal flow graph, it is a point which is used to represent either a summing point, a takeoff point, or any variable. So when we are transferring a block diagram into converting a block diagram into a signal flow graph, so we can replace the summing points, the takeoff points, and any of the variables by the node. Okay, so node is a point which is used to represent summing point, takeoff point, and any of the variables. Second term we have is input node. Now input node will be a point where all the signals are going out of it. Okay, or we can say that the input node, it is the source of outgoing branches. So if this is a node, then it will have all the outgoing branches from it. So this node will be called an input node. Then we have the output node. So output node will have all the incoming branches towards it. Also known as sink node, and receive incoming signals. If we take an example, if this is a node, then all the branches will be towards it. So this will be an output node. It is receiving incoming signals or branches, also known as the sink node. Then we have mixed node. Mixed node, it is a combination of input node and output node. Means it has both incoming and outgoing signals to it. So mixed node, it is a combination of both input node and output node. If we represent it, suppose it's a node, so it is having incoming branches also and outgoing branches also. So this node will be called a mixed node. Next we have term as loop. So loop is a closed path Loop will be a closed path which starts from a node and terminates at the same node, and the loop will goes in the direction of flow of the signal, that is in the direction of the arrow. So if we take an example, this is a node x1, we have another node x2, so these we have two nodes x1 and x2. The loop is starting from this x1 node. It is going in the direction of flow of the signal, that is in the direction of the arrows in this way. So starting from x1 and terminating at x1. So this will be a loop. Let's take another example. Now in this case we have, if it goes in the direction of flow of the signal, then starting from x1, g1, g2, this is not the direction of the arrow. So the signal will go again in forward direction. So this is not called a loop, because we have to move in the direction of flow of signal or in the direction of the arrows. So this is a loop and this is not a loop. Then we have non-touching loops. Non-touching loops are those loops which don't have any node in common between them. Let's take an example. Now in these two examples, let us consider this first case. In this case, these two loops are there starting from x1 to this node, then again terminating at x1. This is starting from this node going to x2 and terminating at this node. So these two loops, they have one common node here. So these are called touching loops. If the loops don't have any common node between them, then those loops are called the non-touching loops. So this will be the example of touching loops, and it is an example of non-touching loops. So we can say that non-touching loops are those loops which don't have any common node in between them. Now the next term we have is the forward path. It is a path which originates from an input node and terminates at an output node. Also, when it is traversing at this path, that is starting from input node and terminating at the output node, no node has to be encountered twice. That is, it is not going to cross any of the node two times. So forward path, we can say that a simple forward path will be like this. It is starting from the input node and terminating at the output node, and no node is crossed twice. More than once, no node is being crossed by this path. If we take another example like x1, x2, it is going this way. So if we see this x1, x2, x3, and this is not the direction of flow of the signal. So the signal will flow from x1, x2, x3 and x4. So this will be the forward path. Also x1, x2, x3 and x4, this can be the forward path. This is not the path, this will be a loop. Okay, so these are the terms which are going to be used when we are studying this technique, signal flow graph. Now next we will study some of the rules which are related to the signal flow graph. First rule is the addition rule. The addition rule says that if we have, suppose, an example here. Now these are the four branches from these four nodes x1, x2, x3 and x4. These are the input nodes and this is the output node. All the branches are coming towards it, so it will be a summing point. So if we take the output here, so x will be equal to this path gain. Path gain, it is the gain of this branch. Okay, so a11 has to be multiplied with this input. So a11 multiplied with the input x1 plus a12 multiplied with x2 plus a13 multiplied with x3 plus a14 multiplied with x4. So we can say that the value of the variable which is designated by a node, it is equal to the sum of all the signals which are entering to the node multiplied with their gains. Okay. So at this node, the value of this variable will be equal to the algebraic sum of all the value of these variables, sum of all the signals multiplied with their path gain. So this was the addition rule. Second rule was series connection. This rule says that if we have this node as x1, then this is x2 and this is x3. This branch has the gain h1 and this branch has the gain h2. So these two branches, they are connected in series with it. So they can be replaced by a resultant which is starting from x1 ending at x3, and their gains will be multiplied. So we will have h1 and h2. So this is the series connection rule. Now the third rule is the transmission rule. Let's take an example. We have this as the output node. The branches are coming out towards from it. So we have x1 and x2 here. So a11, it is the gain of this branch, and a12, it is the gain of this branch. So this rule says that the value designated by this node, it will be transmitted to this node. So we can say that x1 will be equal to a11x and x2 will be equal to a12x. So the value of this variable, it is equally transmitted to both these branches. It is not like that it will be divided between the two. It is equally transmitted and it will be multiplied with the path gain. So these are the rules which are used in the signal flow graph. So in this video we studied that what is a signal flow graph, and what are the terms which are used in the signal flow graph technique, and in the last we studied the rules which are related to the signal flow graph technique. So I hope that this topic is clear to you. Thank you.